Brilliant. So the last section of this morning, and I'll try and keep it brief so that we can finish by 12:30 as planned. We've looked at some of the foundational issues and learned some of the foundations of AI and machine learning from Nathan. We've learned about elements of the ethics of medical AI and how it's deployed from David. Clone has talked us through some of the regulatory, quality and standard issues, and I'm just going to bring us home by looking at some of the ways that it's actually deployed currently in clinical practice in the NHS. So deployed clinical AI, is it fact or is it fiction? And one of the important things to bear in mind as we look at this is to look at maybe in the US, because there's a bigger data set there, but of the number of different software as a medical device, or SAMD, approvals that have gone through, and the distribution of those throughout different medical specialties. And you can see that this is looking at data between 1995 to 2022, there's a clear front runner, which is radiology. And the reason for that is because computer vision is way ahead in terms of the data sets that are being used and can be trained using some of the techniques like convolutional neural networks that Nathan talked about earlier. And when I was first learning about this, one of the key things that I didn't really understand was how a computer could see and how computer vision actually occurred. And so one of the key areas I work in is osteoporosis and in bones and in fractures. So here we have a cartoon image of a bone. And what the computer actually sees is not a bone as we see it there, but is more like a pixelated bone with pixels being black and some pixels being white. But if we drill in further to what the computer's actually seeing, it's not seeing pixels as white and black boxes, but actually as numbers relating to a level of intensity with ones and zeros. If there's grayscale in between them, that can be anywhere in between those two numbers. And if we look at this box that we have here of a digital bone, we actually no longer really have a bone, but we have a mathematical matrix. And we can therefore see that that mathematical matrix could be subjected to some of the complex statistical analyses that are used and ultimately used in order to identify an apple, as Nathan talked about, or in order to label an iPod, hence leading to the confusion when the apple was labeled as an iPod in the example that he gave. So that's just in order to give a brief background to computer vision. And it's relevant because mammography is one of the areas that's really ahead, and I'll talk about a couple of examples in a moment. But this is just a paper talking about how deep neural networks are used to improve the analysis of mammography, which represents a huge burden to radiologists through the very important breast cancer screening that's performed. And so it performs tasks such as segmentation of lesions of interest and then highlighting them and labeling them, and then using heat maps to determine or highlight areas that might be more akin to malignancy and some that might be more akin to benign tissue. And if we look at performance of these, and within the field of certainly classification problems, the area under the curve, or the AUC, of a receiver operator characteristic curve, and these were a series of data visualizations essentially that came out of radar work that was done in the Second World War, and plots the false positive rate against the true positive rate. The important thing is how much area is underneath the curve, and if it's just 50% represented by a straight line seen down the middle, then it means that the classifier is actually no better than tossing a coin, and so it's just random. But the nearer that area under the curve moves towards 1 or to 100%, the better the classification, such that 1 or 100% would be a perfect classifier. And we see the variation in human performance on the left with reasonable areas under the curve of 78%, and this is in identifying cancers, but that improves if you incorporate a computer into the loop up to 0.89 or 89%. And this is what has really led to a drive in industry towards producing tools that can do this. And there are a couple of examples here: MIR, which is produced by Chiron Medical Technologies, and also Transpira by Fusion AI. And these take mammography, importantly, anonymize the DICOM images before subjecting them to the analyses, and then can highlight, as we see on the right here, areas where malignancy might be suspected and that require further investigation by radiologists or by clinicians. And so aim to reduce the burden on radiologists and improve efficiency. It's also being used in, AI is also being used in stroke assessment, and NICE approval for this went through in about July last year. And this is an example of one of the companies that work in this area, Brainomics. And they highlight areas that might be, highlight areas that are suspicious for stroke. And so aim to improve the performance of radiologists in reporting CT scans in that important window when we're trying to decide as clinicians, are we going to deliver thrombolytic therapy for a patient, or are we going to hold off because it may be too dangerous or not worth it? So that window is small, and this aims to assist in that decision-making process. There are also trials that are going on in other areas, and this is highlighting a tool produced by Nanox AI, which aims to take routinely performed thoracic and abdominal and pelvic CT scans, then recreating sagittal images of the spine such that vertebral fractures can be identified from those. And then those people in whom those vertebral fractures are identified can then be fed into fracture liaison services. And this is really important because vertebral fractures massively increase the risk of future fractures of any fragility fracture kind, including hip fractures, and hip fractures associated with a really substantial 12-month mortality rate. And this is all part of the ADOPT trial, which is being run out of the University of Oxford, but also Southampton is one of the centres for that. So that's an idea of some of the computer vision work that's going on. This app, Sleepio, has moved forward as an example of cognitive behavioral therapy, which is being driven by an AI algorithm behind the scenes and is being used to treat insomnia. And this isn't in active deployment, but there's of course a lot of noise around natural language processing in general, and we've heard much about that. And this graph's really interesting because it shows the huge performance in large language models. So these large language models may not just be general large language models like GPT, but these may have been trained specifically, certainly in the example of MedPalm, which is produced by Google, on medical data. And we see that the performance when these algorithms sit the US medical licensing examination, or USMLEs, the examination which is sat by all medical students in the US, so as to determine which jobs and residencies they may move on to, that the performance has improved really over the last 2.5 years, to getting about a third of questions right, to in December 2022 getting about 2/3 of questions right, and importantly crossing the threshold for a pass mark, which is set at about 60%. And even more recently, if we just see, MedPalm 2 actually improved its performance up to 85%. So we can see that these large language models are very good at holding medical knowledge. But of course, we hope that doctors may be better at demonstrating empathy. However, there was this study that was published in JAMA in April of this year, which took 195 questions that had been posted on the Reddit Ask Docs stream. So this is a stream on Reddit where anyone can go on and place a medical query, and then there's a moderator which only allows people who have medical registration to answer the questions that are put, and so to provide medical advice to these questions. So what the what the researchers in this case did was they took 195 questions from here. They took the answers that had been given by the clinicians on the website, and they compared it to the answers that would be given by ChatGPT. And then 3 clinicians, so 3 researchers, graded them on quality and on empathy. And the results are quite interesting because certainly in terms of quality, we can see that a higher proportion of those answers given by the chatbot were good or very good compared to the physicians. So the distribution in the chatbot is kind of skewed towards better performance. But also there's a skew towards more empathy being demonstrated by the chatbot than by the physicians. So does this mean that we're now going to move towards a world in which AI is going to outperform us, and we're going to have things like this, a medical avatar?
Hello, I'm Nick Fuggle's AI avatar assistant. How may I help you today?
Are we going to move towards this? Is this the future? Well, I think there are some important caveats to notice when we look more closely at this study. And certainly when there's an example of a reply that has been given to a query about osteoporosis on that stream, and you can see actually that there are some grammatical errors that are made. So for example, if we look at line 4, it said you mums rather than your mum's quality of life. And the writing isn't quite of the quality that you'd expect from the GPT model. And so I think there's probably heavy bias in terms of the reviewing of this. And so I don't think that doctors jobs are in threat yet, but it'll be interesting to see how these things develop in the future. So in conclusion, within deployment, computer vision seems to be most ubiquitous, and certainly in the areas of mammography and stroke assessment. But I think we will see, and are increasingly seeing, great potential throughout the rest of healthcare, and particularly in some of the low-hanging fruit that's to do with administrative tasks. For example, ensuring that letters are written effectively and communicate effectively to patients and clinicians alike. Brilliant. So I'm going to stop sharing there. We've now got, we're at 25. Welcome back, Alicia. If anyone has any last questions or queries, then please do pop them in the chat. And just to emphasize the fact that this is the first chapter of the Clinical AI Summer School, and we will be inviting you to partake in our practical. A little bit about that. So that's being produced by a Turing enrichment PhD student called Tim. Both Emma and I and Alicia have been involved in that and been reviewing that over the last few weeks, and it looks really exciting and actually is a really practical way to put into practice some of the concepts, particularly that Nathan talked about earlier. So tuning parameters within a neural network in order to improve performance within an actual real life computer vision classification problem. So it'll be really exciting when it does happen. We'll either try and run that virtually or face-to-face. Will the recording be sent around soon? Emma, you might be better answering this than I will, but I think usually it has to go through one of the teams at Turing before it can be posted online. So yes, it does actually happen quite quickly. But what do we think the lead time is on that? I'd say like 3 weeks.
Yeah, a couple of weeks, I think. I think we need to just check with the speakers they're happy and then go ahead with putting it. So it will actually go on to other Turing YouTube channel, and I'll make sure we have a playlist for the summer school. So yeah.
And of course, if we do manage to move on and meet together, then that'll give us a great opportunity to, actually see each other face to face and network and feed into some of the other opportunities. Oh yes, so Sam's asking, what are the opportunities for getting involved in projects? The best way to do that, Sam, I don't know if you're already a member of the Clinical AI interest group, but there are opportunities that are coming out there. So for example, we're just coming to the end of a musculoskeletal AI review that was a call was put out a few months ago for. We're looking for volunteers to help write case studies to feed in some of the educational activities of the Turing. We've also got a Turing Roche collaboration event around barriers to deployment of clinical AI, and that's going to come up in October. We've got a collaboration with the Neurotech UKRI network. That's going to be based in November. So there's a number of different avenues to get involved in, but the first port of call would be to sign up to the Clinical AI Interest Group. And then we can, also feed you into one of our supra interest groups as well, depending on your area of clinical interest. Kindly provide shadowing opportunities for research available. Well, I mean, Alicia, I'm sure, is always looking for people to volunteer as well. But yes, absolutely. I'll pop my I'll pop my email into the chat, and please do get involved. Get in touch if you want to get involved in any research in this area. Alicia, anything else from you?
No, I don't think so. The other thing would be, if you're interested in some of the different projects, you can, on the Turing website, you can search by topic or area, and there's a health and medical sciences program that covers a raft of different areas as well too. The Turing itself has just released its updated strategy for moving forward, called Turing 2. And one of the grand challenge areas for Turing over the next 5 years is health. So just as we're kind of transitioning into that Turing 2, there will be much more coming in that space. So the best way, as Nick said, is through the Clinical AI group. But it's not just Turing, it will link you into researchers across the UK, and actually we've got some international groups as well too that are members too. So
just to highlight a couple of other interest groups that people might be interested in. So if you're a mental health professional, then there's the mental health data science and mental health interest group. There's the health equity interest group, which is addressing this really important issue, and definitely one to look out for and get involved in. And of course, the health program in general.
Yeah, and my background's in public health, so I'm actually discussing with the Faculty of Public Health the potential for bringing together people that are interested in the application of AI across populations. So not necessarily at the clinical bedside, if you like, but in that space too, but all focused on prevention, which is where we all like to work. I think that's it for today. It's really been fantastic. So thank you so much for your engagement and questions on Slack and in the chat as well too. We really hope that you've enjoyed it. It's been the first one that we've done, so we hope that it will grow and grow, and we will, like we've said, come back in touch with you all about the practical as soon as we can. So if you don't hear, it's not that we haven't forgotten. It is coming, so just bear with us on that one. To keep up to date with the Clinical AI group, we have sessions monthly. Monthly sessions tend to be on a Tuesday around lunchtime. The next one's on Tuesday the 12th of September at 12 o'clock with a focus on omics theme. So you can, if you sign up to the Clinical AI group, you'll get the details for that, and then do come and join us for that one. And if you want to get in touch about other ideas or requests or things, then we're always open to that. So just reach out to any of us individually or through the Clinical AI group as well too. So a huge thank you to our speakers, a huge thank you to Emma, who has really managed to pull this all together with and adapting us and helping steer us through that process with all the different strikes that and things that we're trying to manage. And a huge thank you to Nick as well. So I think that's it from me, unless Nick, you've got anything else?
Not at all. Au revoir.
Lovely. Have a lovely afternoon, everyone.
Bye, everyone. Thank you.
Bye-bye. Bye.